Increase the brightness. So you need to repeat this chapter. So the basic and the first difference between classical and PACS is like for classical, uh, we need, and there is not a basic difference because for classical we can also do with docking or without docking. But for PACS, we actually don't need dock structure. Okay. So for this, uh, I need to open your structure PDB. Can you tell me where it is? I think your whole system is too much zoom in. That's why it's not clear. Can I make some changes? This is okay, I think so. If you want to change, you can change later. Okay. So ND and okay, molecular docking. Docking, which one? Simulation. Okay. Okay. So this is so which one we are studying, BBM or BBM? Okay. So I will open this one and where are the structures? BCD. Okay. So I will just let's start with BCD. BCD and BBM. Okay. So okay. I need your optimized structure. So mhm, this is your optimized structure. So, okay. For this, we don't need to demonstrate A or B. Okay. So I will do one thing. First, I will copy this BCD. I'll paste it here. Then I will copy the BBM, paste it here. Okay. So, okay. Okay. You can use this to move your structure like this. Okay. And then this to rotate the structure. Okay. So for now, first let me make it the background color. So okay. Now select BBM and we need to move this structure. We need to set what happens. Control. Yes, with control we can move it. Control and then drag wherever you want to drag. Okay, now drag a little bit and now see either it's just you see now it's just looking like on the top of the cavity. Is it right? Okay. So now we can do one thing that is okay. Now the distance between the center of the cavity of the BCD and the center of the drug should be like your drug is not that much big, so we can use the distance like 20 angstrom. Normally we use that. So to set a distance, we will choose. Okay. So first I will make a little bit adjustment like this. Then I think if I set from this carbon, this is gonna be a better option. This is looking like the center of the structure. So I will choose this carbon and I will make a little bit adjustment. And for this, we need to choose the oxygen that connect two together. So for this, I will one already selected, and for the other, I will use the shift. Yeah, you see, both are selected. But this is like here, this side. I need to make it just okay. I will choose one of the oxygen from the primary. No, this is not primary ring side. Oh my god. This is a secondary ring. This is a secondary rim, this is the primary rim. So primary rim should be at the bottom. So I need to move this drug. I will move this. I will move it here. Okay. Make it like this. Then I will select the BBM. I will move it here on the top. And now I will move it a little bit. Now I want to see whether it is on the top or not. It's not a little. So I need to move it a little bit more. Like this. Okay. You understand? Okay. It's quite better. So now I will move it like this. Okay. I need to choose this carbon then and the oxygen that connecting two units together from the primary rim side. I will choose that oxygen, this one. Now the both are selected, so I will go to chemistry, then bond. No, sorry, this one. Structure, monitor, and distance. Okay, go to structure, then monitor, then in monitor is a distance. Okay, I will click on distance. Now you see it's a 15. So I will choose this BBM and I will try to move it a little bit, and you will see I will increase the distance. I want to make it I just want to move this. I will make it 20. I think this is okay. I mean 20.01 is not wrong. So this is okay. So now this is the structure that we will use. So I will just remove this distance. Okay, so now, okay, one more thing we need to do is we need to drag this BBM under this BCD. So here we see now this is another symmetry. Okay, so from here you can also change it to mode because we need it to go. Okay. So now I will save this structure file, save as, and I will write BBM. Is it right name? BBM. Okay, volume D. Molecular docking. Okay, awesome. Okay, here I will generate a new folder LB MD. Okay, and for LBPaCS MD, this is for BCD. Okay, BCD, and this is add hydrogen water step. We are gonna do. So here I will save this. So, okay, so now I will go to here LBPaCS MD, BCD, add water. This is the structure. Um, Maybe let's open it with Okay, so we already have one atom correction, so I will just copy that. So where it is, B and molecular document, question, and where, okay, simulation and atom correction. Okay, so all these are correct. Okay, so I will open one of them with notepad. So I will just copy this one. Control C, and I will come here and paste it here. And we need to okay, we need to replace this U and K with mole. U and K with mole because system recognize it as a mole. It's not just okay. Now the second step is to what what we what we will write here. Plus 8. Then we need to remove this connectivity as well. So we remove it until here. We need end. Okay. Then is good. Okay, is good. So we remove this one. Okay. Control. Okay. So now this structure is ready for the add water step. So okay. So for add water, BCD, we need this code file in file. We need glycom. Where is glycom? LBPy and that file. We need run file and we need VBM for remote files. So I will move it. So in total we need 10 files. Okay, now I will change the name in add water file because this name is now changed. I will write it. Is it right name BBM or BBF? It's BBM. It's BBM. Okay. So BBM. Is it right? I mean, all the things. Okay. Save. Now I will just drag this trajectory here. Okay. LBPaCS. So I will create a folder here. Okay. This is BBM. Okay. BBM. LB. That's now you can write BCD. In BCD, drag this out. Okay. Now we need to run the same step, CD and paste. And now, okay, I will say first module load amber because it will get this error. Module load amber. Then I will write okay TLEAP minus add 0, 1. Okay. So the same error, I remove the hydrogens. So okay, we will remove the hydrogens. It's from which one? Okay, 34. 34. Okay, we will remove these because we don't need these. Okay, so I will save. Let's represent this one. Okay, I will run again this command. Okay, now it's working. Okay, so first step is done. Now the second step is to do the one min. Okay, so the same step, draft run. Okay, first we need to make it readable. Chmod plus x. Okay, I will write the name of the file run min. Now I need to run it direct. Run min and okay, I can write the top to see is it running. It's running. Okay, I will copy this. Your password. M is capital. MASUM. Okay. So the second step will be to submit the LBPaCS. So for that we need this. So I will just drag this folder here so we can prepare the files. I will suggest you to create folders here in your system for each, then just drag and drop. You don't need to modify each time. Okay, so for LBPaCS, you see we need two folders. So I will little bit demonstrate you about this one. Okay, so all these are the command files. We don't need to do anything with these files, but we will just change two files, that is add water file, topology file that we got from the 01, and the min or restart. We need to just replace these two files with your files. Okay, first thing, and for second thing, okay, these are the actually the files. I told you like it will run in small steps. I will show you as well with my so we don't need to change anything. Just to replace here two files, and in this folder min distance you will get the distance while running the simulation. And if you look at these structures, these command files, you will understand the, you see, here are the parameters that we are basically using. So here the nstlim is 50,000. So if you multiply 50,000 with 0.002, what is the answer? Okay, you calculate this and tell me how long it will take to run. I mean, how much time for one cycle. Just solve this NS, TLM and DT. I told you last time. Now do this. Yes. Multiply these two. Okay, my system is updating. So it's a 50,000 multiplied with 0.002. 100. Okay, so it's 100. So what is 100? 100 nanosecond. Picoseconds. So now if you want to convert picosecond to nanosecond, what we will do? 1 nanosecond is equal to 1000 picosecond. So it means this answer is in picosecond. So we will divide this answer by 1000. So the answer now, then answer will be in nanosecond. Yes, divide this by 1000. So now the answer will be in nanosecond. So now tell me how many nanoseconds we have. 0.1. Yes, good. 0.1. Okay. So this is 0.1 nanosecond for one cycle, not for one cycle, for one candle. Yeah, and last time I told you how many cycles we will have? 100. Total 100 cycles. And in each cycle we have two candles. Yes. And one candy is equal to 0.1 nanosecond and two candy will be equal to 0.2 nanosecond. So if we want to calculate the total time of simulation, how long it will? Yes. So one cycle is equal to 9. Now one cycle is equal to 0.2 nanosecond, right? 0.1. No, because one cycle has two candies. So we will take two candies time. Multiply by 100. 20. Hmm. So, okay. So it means this is 20 nanosecond simulation. And that is not good. That is not enough for us. So at least we will run it for 200 nanosecond simulation. So what we will do? Where we will change. Where we can change. We cannot change the cycles. 100 is more than enough. So we have to change this. Yes, we can increase the time of the candies. Like it's now is 0.1 nanosecond for one candy. We can increase to 1 nanosecond, not 0.1. We can actually increase it to 1 nanosecond. Do you understand? Or do I need to repeat it again? Okay, increase this. Yes, because now the simulation time for one candy is 0.1 nanosecond, but we can increase the time for each candy up to whatever we want. Right now, if we set 1 nanosecond for one candy, so it means for one cycle is 2 nanosecond. So if we multiply 2 with 100, so it's gonna be 200 nanosecond. You got it? Okay. So to make 1 nanosecond for one candidate, where we will change? We will change here. NS trillion. Here. This NS trillion. This is 50,000. You know, we multiply 50,000 with 0.002. So we need to change actually NS trillion. Yes, we cannot change DT because this is the most favorable condition that we are already using. So now think, we have 50,000 NS trillion with the 0.002, like we have 50,000 and we have 0.002. When we multiply this we get 0.1 answer. So I think if we do it 50, just try with this one. Now it was 40, now it's 50. Try multiply these two. Multiply these two. 500,000. Mm-hmm. 50. Yes, 1000, right? This is 1000 picosecond. So if we divide it with 1000, so mean we are getting 1 nanosecond. Am I right? Okay, so it means if we increase the NST limit up till 500,000, so our, you know, one cycle contain two candy, candy 1 and candy 2. Okay, so now one candy will be 1 nanosecond, this will be also 1 nanosecond, so total will be 2 nanoseconds. So it means one cycle is equal to 2 nanosecond, and we have 100 cycles. So if we multiply 100 cycles with 2 nanosecond, we are gonna get 200 nanosecond simulation. You understand? So it means we just need to add one zero here. So it will be now 500,000. Yes. Okay, so now our simulation will be one trial. One trial will be equal to 200 nanosecond. Okay, and yes, also we can also try with 100, we can try with 200 as well. So this was the idea behind to explain what we can do. So now the next step is we are not gonna try, we are gonna try 10 tries. Okay, I think the spellings are right. Okay, correct. So we're gonna 10 tries. So it means if one trial has 200 nanosecond simulation, so 10 gonna be like 20,000. So what do you say? I think if we try 10 trials, if we gonna try more and more tries, according to me, I think Ajahn will say, okay, we need to try more. So in that case, I think if we go with the 100 nanosecond simulation, that will be a good idea. Because this is just a drug and carrier simulation. So for these kind of systems, we don't need to run too long simulations. Okay. So I explain all these things to you just to explain to you get what is the actual time calculations that we need to do. So if we are gonna try 10 trials, I think if our one trial is equal to 100 nanoseconds, that is a good idea. What do you say? Is it good or no? Because one trial 100, 10 trial will be like 1 micro, I mean 1000 nanoseconds. That is more than enough. We can go with 100 nanoseconds. So for 100 nanosecond, if we multiply this, I think you did not calculate the right, because this is 100 nanosecond. You try with 5, this, yeah, 5,000, no, 50,000 multiply 0.002. Is it 100? Can you put it here? And if we go with, these are the four, we go 1,000, 1,000, so 1,000 gonna be like, no, it's gonna be 1 nanosecond. So 1 is gonna be, no, why? It's changing different. 50 into 0.002 divided by 1,000, 0.1 into 2, 0.2 into 100. No, We will go with the okay, we can try is a 50,000, so we can go with 250. Okay, 3 to 5. Okay, 0 0.002, 5,000 into 100. Okay, 250. We go with this one. 500 into 1,000. 1,000 into 2, 1. Okay, now it's good. Okay. So it means 50 into 2. Yeah, if we go with the 250,000, so our simulation will be equal to 100 nanoseconds. So I need to change it to 25 and 40. Okay, 25 and 40. Is it right? Okay, so I will save it. Now our one trial is equal to 100 nanoseconds. Okay, so let me check. Is it done or not? It's still running. Okay, I think it's almost done, but let's just wait for maybe 1 or 2 minutes. Okay, so we will just take two files from there, and then we put it here, and to run this, as you see, like all these are sh file. Okay, so we need to make them readable. Oh, first, I mean, when I will upload the folder in the MobileX term, I will come to this directory in the MobileX term. Then I will make them readable. Then I will come to this as well. I will make them these files also readable. Then I will submit my submission. Okay. So in case now you can see, like, we just set uh, drug and carrier at a specific distance, no docking. So now we can compare these results with docking as well. Either our drug can give us the second confirmation or not. So that's of the docking result. For this, we don't need dock. So that's because we already setting at a specific distance. But from these results, we can also compare with the docking. Either the docking results are good or not, or is it the same or not as well. Like in this case, maybe we get the second confirmation that we are not getting with the docking. So in this case, if the docking results are not good, maybe we can try some other tools just to compare with that. So that's why on that day, Jan was saying, like, uh, we can try PACS to compare with docking, because for this, we can get both simulation and docking as well. So this is the whole procedure. And for PACS, actually PACS is like uh, need our attention. For classical, we just submit the job and okay, we are now waiting for the, if we get some error, we will resolve that and all that. But for PACS, it's take our attention. Like when I will submit the simulation, like in this, we are using two candies. So our job will be fragmented into three types, three jobs. One will be the our main job, and one will be candy 1 and candy 2 as well. So when I will submit the job, so you will understand more better what I'm saying. So now we just need to wait for this one, and I think it's already done because yeah, your job is done. So I will now move these two files to your system uh, here in the module. I will delete add water top file and min or restart files. I will drag these two files, restart and the top file. I will put these two here. Okay, so this is the LBPaCS. Okay, so okay, here I will say okay. You what you want to write? Trial one something, whatever you want to write, or just 1, 2, 3. Trial one. Trial one. Trial one. Okay. So I write trial one. I think if I write. Okay, so I will now drag these two folders in the trial one. Okay, now we need to define the path of these two files, like our topology file and the restart file here. So I will copy this path, and now you need to come here in the command folder and in the run.sh. Okay, open this one, and I need to you see this is the topology file, this is the restart file. If you see here, so I just need to replace this path. I need to define, okay, here are my files. So I will just control V. Okay, so two candy, oh good. Okay, here I will change the name. What is the M? M H M A H M A A G D R. A G D R. Huh? No. M H MAHEDI. Okay. MAHEDI. Okay. That's MAHEDI. Right? Okay. Save. You just need to do these two things. I mean, just define the path of topology and restart file. And where are these files? These are files. These files are here in the module. Okay. When you define it good, then go to file and sorry, into info. Come here. Copy this path. And now I told you we need to make them readable. So I will say, okay, cd, come here. Now I will write chmod plus x. Okay, when we need to make readable files that are more than 1 and 2, so we will use the star. Star is to indicating like all the file with this extension sh make them readable. Okay. So now I don't need to make them one by readable. And if you want to check either it is readable or not, just type ls and you see all these are green, so it means these are readable by the system. Now I want to come here. So okay, I will type cd, just go back one step back now using command. So I want to make this readable, so I will use the same command csmod. All the files in sh, just make them readable. Now again ls, you see all them readable. So now everything is ready to submit the simulation. So now we need to submit the simulation, we will actually run this file run.sh. So you need to be here in this directory. I will use the command sbatch and make sure, because these are gonna take 3 jobs at one time. So in your system, no other jobs will be running. Okay. Sbatch and run.sh. Okay. So now you check my queue. No. Is there any error? like there is no error as well. Mm-hmm. I use the underscore here. Actually, to run this job, we have to we can run it in two ways, either behind on the servers or on the front desk. So this is the command to front desk. Like it will show you everything on the screen, but side by side is also saving here. So I'm just trying to see why it's terminated. So whenever we are running on the screen, we cannot shut down our system. But if we use the SBash, then we can shut down our system because it's running. So it's trying running behind. No. This drag command is running on the screen. So this, you see, this is now running on the screen. So I just want to see why it's just terminated, and there is no error flag as well. Okay, it's running. You see, now it's generated the folder cycle 0. You see candy 1 and candy 2. So in each candy, we will also get some files. This is an example. You see cycle 0 to cycle 100. So this will run be like this, and if you open eCycle, in eCycle we got these files. So in these all cycles, main files are NC files, and this RST file will be act as a input for the next cycle. So you see in each folder we will get these files. The main files are these NC and RST files from each cycles. So now it will generate the page. So we are going to use this NC file from each cycle for our analysis.
You all have to practice a lot. Why these things is so much complicated? I mean, just one maybe or just trying to generating adding water, but I've spent more than 5 hours. Parameter are not generated. Why these things? Why?
You know, uh, When I started working, before coming here, I even don't know the ABC of these things. I don't know what are these stuffs. I never use this kind of. I mean, in my bachelor, I did the experimental work. In my master, I did the computational, but that was just simple DFT study, no these kind of simulation. So I was new also. So I can also understand your situation because when I started learning from Aman, I was used of that person. Like if I'm getting some errors, I was not coming to him because I was saying like he's busy, I'm disturbing that person, all that blah 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 blah. So I just try by myself a lot of time just to solve a lot of problems. And I was also afraid at that time if I did it like this way, is it right or wrong? I don't know. So yeah, when you are new, it will take time for you to learn all these stuff. But
Really must because these things, I don't know what's wrong with me. I feel like it, because if you try but you didn't get the result, and maybe some sort of mistake you're done, you're repeating.
mm,
And lot of thing actually, I can't, my brain I think so slow, it doesn't work sometimes.
I will suggest you one thing. Whenever you get error, just text me. Don't think like I'm a busy person or whatever. Like when I know your problem, I will know, okay, whatever these kind of situation, I can actually, if I cannot do by myself, I can guide you. Okay, try this. So don't waste your time on doing all that stuff too much. Try by yourself one, three times, four times, five times. I mean, not like 4 and 5 hours on that. So whenever you got any problem, just text me. Because every time, whenever I talk to Ajan, she always asks me about your report, like what is going on. So no, just this is my suggestion for you. I mean, I can do these things. I can suggest you. I can guide you. So it's after that it's totally depend upon you what you want to do. So whenever you got any kind of problem, you have to let me know. When I will know, I can guide you.
My communication skills are very bad. At the beginning, I was too much introvert in nature, so my connection with other people certainly. I just try to hide myself. This kind of
No.
attitude I have grown.
So that's why I was on that day, I was telling you just come to lab. When you will come to lab, you will interact with us. And also, if you are not, I will suggest you just to come to lab. You will be like a person, okay, you are coming out of your comfort zone, you are dealing with people, you will learn a lot. And you will, and I prefer to learn and to teach one on one. Not, I'm not a Zoom person. I mean, at that time, I mean, I can explain you if it's urgent, something like that. We can do all that and everything. But yeah, I will say you come to lab. Ask me, ask Aman, ask Saba, ask Kicks, whoever you want to ask. Because in this lab, everybody is doing simulation. But for class packs, me, Saba already done. Aman also know about this one. I already done this one. So you can ask us. Maybe other people don't know about this one. But the main point is just to come lab. If you got problem, just directly come to us and you can ask if you have free time, whatever, in which way you can ask, you want to ask. Just ask and let us know your problem.
I will try.
If you are in your room, you are trying something, you can text me. Okay, I got this problem. I need your help. Okay, you see it's running. If you look here, so here is also show the error with the cycle 0. Let me just check cycle 0. So now you will understand the errors. Okay. So if you see in candy 1 of the cycle 0, it does not generate the NC file. You see, it does not generate the NC file. Here is the error. If this cycle does not generate the NC file, next cycle cannot take the input file. But the other, if you check the candy 2, it's already NC file here. So it means the candy 2 of the next cycle will take the NC file from here and it will continue. But the candy 1 will not. It will give you error in each file. So these are the errors that I was talking on that way. We need to repeat it again and again to get the two candies. So that is the problem with the LBPaCS. We need to try it a lot of times.
Then how can
Okay. So if you look at sometime it will generate the NC file for the next cycle. But the problem will come, like for example here we didn't get the NC file with the candy 1. But sometime the other cycle, like cycle 0 don't have the NC file, but cycle 1 will generate the NC file. But problem will come when we do the analysis. From cycle 0 we don't have the NC file. We need the NC file of all cycles. So in this case, we need to just run it again. No other thing. We need to just run it again. So I do it like, you see, now it's just generated the NC file for the next. So let's see. Let me check for the cycle 1. If you look, it's generate, it does not generate the NC file as well here. But it generates the NC file. In cycle 2, it will be the same. Candy 1 don't have the NC, but Candy 2 have all the
so
NC.
it will automatically generate all the cycles?
Yeah, is we already we already set a system, like it will generate the folder, and each folder it will put the input files in each folder, then it will run it.
So suppose I have run the 100, it will generate the 100 cycle, right? So suppose it's generated 100 cycle, and each of cycle, one of candy, it doesn't generate a fancy file. Each of cycle it all shows these.
Yeah, I'm telling you that point. Like sometime, most of the time, it will not generate the NC file in other cycles as well. But in rare case, sometime it also generate for others. Like in 0, we don't have, but in 1, it may generate the file.
Then I will have to repeat this cycle again.
No, you in that case, I just repeat that cycle. Like if I don't get the file for the 1 cycle, I will just repeat that cycle 1, not all.
So
We can specifically just can repeat that cycles. So I prefer to run on the CPs because with the CPs we get less error as compared to this one. But probably just like you can say 19-20 differences. So we will submit the file with here. I will stop this file. I will check. Oh, sorry. My queue. Do we have any job? No. Okay. Now I will just delete these two. 3. Okay. I will come here and I will submit the job. CDS batch 1. I generated all these notes when I was learning, when I started learning these things.
So how do we generate a meal?
I mean, for example, now I'm just learning from Aman. Then I'm going to my seat, I'm repeating all the steps, then I'm writing with myself with the snapshots like these are the steps, do like this.
That's a great idea. Because I think if you're learning LBPaCS, over the time it will delete everything. Right?
I tried a lot of time, like, I mean, I tried like 40 trials with it. I mean, I think I run it over like 500 times. I'll be back. I think the command is correct, but why it's not really needed. Yes, I forgot to tell you this one. In distance stored as such, we need to define our ligand as well. As you see, one side.
Why did you change it? Distance?
Distance mean it will calculate the distance between the atom, sorry, between the cyclodextrin and the ligand. So we need to define like what which one is our ligand and which one is our receptor. So 1 to 7 is our receptor, that is BCD, and 8 is our ligand. Now it will consider it as a one structure and 8 as a one structure. So it will calculate the distance between these two. So after this, mhm, okay, is the right command as that. So why it's not giving error? Cycle one. These are the things. Okay, let me find the solution for this one, but now you can use this command to run. Like 1 to 2, I define it just to see whether it's running or not. So 1 to 2 mean just cycle 0, 1 and 2. So if you write 1 to 100, so it will run up till 100. So you may can run it in shorter times, like first run 1 to 10, then run 11 to 20 something. If you want to run for all, you can also do that. If you want to run short, you can also do that. So let's say if I just run it now 1 to 10, so you can do that. So when we are running like this, you cannot do any stuff now on your system.
Change it.
Yeah, you can, I mean, you can minimize and maximize. You can maybe use the other people's account, but you cannot do any kind of calculation on your system. Okay, so just make sure when this is running, when one cycle is complete, and check the next cycle, next to cycle, then check this one, the previous cycle, either you got the NC file with both or not. And you can also note down with yourself. If you are not getting file with you that one, you can note down, okay, in one trial I don't have the NC file with this cycle, then we can just repeat that cycles, not all. I mean, rather than checking one by one all, we can just do that. Yeah. So you can do your other stuffs, but it's still running. So
A lot of takes to generate all the
for this one, sometime it's dependent upon the system whether they are busy or not. Sometime it will take like just in 4 hours it will be done. Maybe 5 hours, or sometime it take more time as well.
after getting the file, then how you analyze this.
So we will use the NC file for the analysis. First thing that you will get is the distance. Distance is in this mean distance in this file. Mean distance, if you open this one, so you see it's a distance 23 between the drug and carrier. And by checking distance, you can also imagine how closer the drug is already getting towards the cavity. Like if your distance is coming into 0 point something, it's mean the drug is already inside the cavity. But its distance is like 1, 2, 3 something, it means it's near the cavity but not inside the cavity.
So it's only three.
Yeah, it's mean now drug is moving around here and there, but our concern is like either it's getting inside or not. So it's just a cycle zero. So I mean, don't bother it. It's just a start of the simulation. One thing that we first analysis we will do is the distance analysis. So for the distance analysis, mhm, okay, I will show you that I done my manuscript. Okay, no, this is okay. So you can see the distance. So initially my distance was like around 20. Then slowly the distance was decreasing and it's coming inside the cavity. So you see here the distance was 20 and now the drug is inside. So you can plot the distance something like this.
The time.
Yeah, the distance is reducing. It means the drug is coming closer to the cavity, and at the end is finally inside the cavity. So you can use other. This is a 3D plot. You can use 3D, 2D, whatever you want to visualize your result. So first thing we will do the this one, and after that we can do other analysis like atom contact, SASA, RMSD, and all that. So to do all that, we need ANSI files. And ANSI files are the main files that we can use for the analysis. Okay, so now for your for your presentation, when you present your these results, uh, add as one or maybe just maximum two slides to describe the steps what you had. I think one will be enough. Like you can say that okay, I optimize my structure, your drug and your BCDs. I mean, just mention your drug because the BCDs are already optimized. You optimize your structure. After that, you generate the parameters, and then you did the minimization, like addition of water and then minimization. And after that, you submit the simulation. And you are using the LBPaCS with the two candidates. And also mention like for your structure, you can just make an image like this, or maybe uh, if you want to make it better or something like this, you take, for example, take this image, mention okay, I set the 20 angstrom distance for my input file, then I go for the minimization and all that. And for simulation you can say like I submit the simulation and my one trial is equal to 100 nanoseconds. And I try, I mean, up till that, if you go two, three, four, how many trials you get, you can show the results of that trials. Okay, so as I told you, this take our attention, so you need to be like check it like after 1 hour, check is it done or not. If it done, just submit another one, because for this you need to get the results with all. Try, I will say you just like maybe we have next Sunday meeting, so how many days you have?
6 days.
6 days. 6 days, how many how many cycle lessons you have? Five. So give one day to each, so you have at least something from each to compare. So I will say in one day, if you are successfully run two trials or three trials for one compound, on the second day repeat the same for the other one, then on the third day repeat the same for other one. So you have 5 days. In 5 days just do this. On the sixth day we do the analysis, so you have something to show to them. You can tell, okay, and Ajahn will also ask you something like how much it take for one trial. So you need to be concentrated on okay, how much taking its time. And if sometime I told you, it's sometime it will take like okay 4 and 5 hours just. Sometime it will take more than that. Okay. So now your target is this. Now it's running, that is good. And now just keep checking if you are getting some errors and all that, whatever the situation is. And beside that, just prepare your other structures. So when it's done, you can tomorrow you can go for the DM, then also this. Yeah, and don't hesitate if you have any problem.
Just now, I have recorded each of single point. So,
So I will suggest you also just note down with yourself. So if you maybe sometime people, I mean, it's a human mind, we can also forget. So it's okay. You can ask me, you can ask anyone.